Welcome. In this video, we're going to be discussing further in depth statistical hypotheses and hypothesis tests, various terms and values that go along with hypothesis tests. So to start us off, I want you to consider the following set of hypotheses. So say we have the null hypothesis that X is an elephant, whatever this X is. I mean, you could make the assumption that it's an animal if you want to begin with. That's perfectly fine. So our null is that X is an elephant. Our alternative hypothesis is that X is not an elephant. So generally, we assume the null hypothesis is true, and then we look for evidence against it. So the two possible decisions you're going to have in this case is that we're going to reject the null hypothesis or we're not going to reject the null hypothesis. So what I'd like you to do is to consider two different scenarios, and we're going to consider these separately. The first is scenario one, that we have the bit of information that X walks on two legs. The second scenario, and again, consider these scenarios separately, that I want you to consider is that X has four legs. So if you don't mind, you can take a moment and pause the video here and just think about this for a couple of minutes. Decide for each scenario whether you would reject the null or not reject the null. If you'd like to, I guess you could find yourself some nice Jeopardy music to play in the background while you're discussing it. So maybe you've already paused me by now. We'll see. I'm giving you many opportunities. All right, so welcome back. So in our first scenario, we have that X walks on two legs. Well, if X walks on two legs, then again, our choices are that we either reject the null or we do not reject the null. Well, think about elephants. Do elephants walk on two legs? No, elephants walk on four legs. So if we have the bit of information that X walks on two legs, well, then the logical conclusion would be that we're going to reject the null hypothesis that X is an elephant and conclude that X is not an elephant. Now, just because the piece of information that we had led us to reject the null hypothesis, does that mean that that decision was correct? Well, maybe not. Do most elephants walk on two legs? No, many do not. However, is it possible? Sure. You could have various circus elephants. If you want to Google elephants walking on two legs, you can actually find a YouTube video of it. So if that were the case, if we happen to have one of these animals as X, well, then we would have made a mistake. Our decision to reject the null hypothesis would have been incorrect. That would have been an error. Formally, that's called a type 1 error. Whenever we're dealing with hypothesis tests, we have two different types of errors that we can make. The first being a type 1 error. The second, which we'll discuss in a moment, is a type 2 error. Statisticians are a creative bunch when we're naming things. So that is our first scenario. In the second scenario, we had the bit of information that X has four legs. Well, if we have the bit of information that X has four legs, we think about it and go, okay, our null assumed that X was an elephant. Do we have evidence against the null hypothesis? No, because elephants have four legs. Now, we don't have evidence against the null hypothesis, so we do not reject the null. Again, be careful with your wording here. You can say do not reject the null hypothesis, fail to reject the null hypothesis. We don't want to say we accept the null hypothesis, however. Now again, does this guarantee that we made the correct decision? No. There are plenty of animals that have four legs that are not elephants. What do we got here? We got a giraffe, we got a zebra, we got a tired little puppy, we got a panther, we got a yawning cat. Apparently the domesticated animals are both tired. We got a pig, tiger, cow. So yeah, does the piece of information that X has four legs, and again, we wouldn't reject the null, does that guarantee that we made the correct decision? No. And in this case, the error that we would have made is what's known as a type 2 error. A type 2 error is when the null hypothesis is not rejected, but the null hypothesis is false. Now, something to keep in mind in both of these situations. Yeah, our decision ended up being incorrect, but does that actually mean we did anything wrong? No. Because the data in both cases, whether we're talking about the fact in the first scenario that X walks on 2 legs, or in the second scenario that X has 4 legs, in both cases, the data led us to the conclusion that we went with. So we didn't make anything wrong procedurally. We didn't make any mistakes in that case. It's just that the data led us astray, more or less. So to put it to a more practical example, we had the example where we were testing to see if long-distance college runners had a mean resting pulse rate of 60 beats per minute or not. So we had the following hypotheses: mu equal to 60 versus mu not equal to 60. So in this case, again, we've got the 2 types of errors that could occur. A type 1 error would be, again, type 1 error means you reject the null when the null hypothesis is actually true. So in the context of this problem, a type 1 error would be concluding that the mean resting pulse rate of long-distance runners is different from 60 beats per minute, when in fact it actually is not. So again, type 1 error, rejecting the null when the null is true. Type 2 error, on the other hand, in this particular example, would be failing to conclude that the mean resting pulse rate is different from 60 beats per minute, when in fact it actually is. So again, formally, generally speaking, a type 2 error is not rejecting H sub 0 when H sub 0 is actually false. So if we want to look at all the possible outcomes of a hypothesis test, so here on the left, on the first column, we've got the 2 decisions. You can reject the null or not reject the null. Then, on the top row there, we've got the truth of the situation, the reality. Either H sub 0 is true or H sub 0 is false. Now, practically speaking, when we're going through and doing a hypothesis test, we don't know which of these 2 options is true. We don't know if the null is true or if the null is false. If we already had that answer, we wouldn't need to do the test. Now, so if our decision is to not reject the null hypothesis, that means we got one of 2 things that could happen. Well, if the null is true, then that means we've made a correct decision. Obviously, that's a good thing. If the null hypothesis is actually false, then that means we've committed a type 2 error. The other decision is to reject the null hypothesis. If we reject the null hypothesis and the null hypothesis is true, that's a type 1 error that we've just been discussing. However, if we reject the null and the null hypothesis is false, then that's a correct decision. So obviously that's a good thing. And then there are values or notation for the probability of each of these errors. The probability of a type 1 error is defined to be alpha. The probability of a type 2 error is defined to be beta. Now, again, alpha is our probability of a type 1 error. And then I've just got some other items listed here, other names for it. Sometimes it's called the type 1 error rate, the level of significance, the significance level, alpha error, the size of the test. So all of these are just different names for the same thing. And then the probability of a type 2 error is equal to beta. Something very closely related to that that's very important when talking about statistical hypotheses is power. And power is defined to be 1 minus beta. So it's 1 minus your probability of a type 2 error. More specifically, the power of a hypothesis test is the probability of rejecting the null hypothesis when the alternative is actually true. Or another way you could think about it, it's the probability of rejecting the null when the null hypothesis is actually false. So if the null is false, what are the chances I actually reject that null hypothesis? What is the probability I make the correct decision in that case? Few last things to talk about with type 1 and type 2 errors. They are related to one another, and in fact, they essentially compete against one another. So if we decrease the probability of one of the errors, that's going to increase the probability of the other. So if we decrease our type 1 error rate, that increases our probability of getting a type 2 error, assuming our sample size stays the same. Now, if we increase our sample size, so if we increase n, then that's going to reduce our type 2 error rate when our type 1 error rate is held constant. If the null hypothesis is false, then the type 2 error rate increases as the true value of the parameter approaches the hypothesized value in the null hypothesis. Likewise, the value of a type 2 error decreases as the difference between the true mean and the hypothesized value increases. So, and that'll be discussed later in more depth, but basically what it means is if we're testing to see, going back to the previous example we looked at, if we're testing mu equal to 60 versus mu not equal to 60, well, if the actual mean is 65, well, then our probability of committing a type 2 error is going to be less than if the actual mean was 62. Why? Because 62 is closer to 60 than 65 is. The last question to look at, well, what value do we use for alpha? The standard rule of thumb, what you'll see in most classes you take, is to use 5%. Where does the 5% come from? Well, frankly, a long time ago there was this guy named Fisher, and he was trying to decide, okay, what seems like an unlikely event? All right, something that only occurs 1 out of 20 times seemed pretty unlikely. So 1 out of 20 is 5%. That's where the 5% came from. And it's kind of stuck, at least partially. For more practical purposes, if you're actually dealing with a scenario where you're doing something out in the field, doing something in a particular industry, different industries have different standards for their value of alpha, their type 1 error rate. Some will use 5%, 10%. Those are typically more your social sciences. The more quote-unquote hard sciences will usually use a smaller alpha value. Same thing if you're dealing with like a clinical trial or something like that. So it really, there's a lot of factors that go into choosing the alpha value. Again, most of the time we'll use 5% as our rule of thumb. In industry, there's usually sort of a standard and then other thought that goes into, okay, what would be an appropriate value for our type 1 error rate or our level of significance here. All right. And with that, that will conclude our video on type 1, type 2 errors and items related to those. Thank you.